All right, we're recording. Oh no, I better check my mic. Mic check. 2 1 2. All right, we're good. I don't know where 2 1 2 came from, but I said it. If I ever had to do a mic check, that's what I do. Mic check. 2 1 2. No idea. That must have been 8 Mile or something. If any of you know what 8 Mile is, I'd be very impressed. Okay, so we got 11.3. So we took 11.1, 11.2 quiz today, which is Thursday. I'm recording it a day ahead of time, so Friday is when this will be. GCF Factoring, last section for the week. Then we got the weekend. Okay, so let's get this knocked out. GCF is really the opposite of where we did the monomial and distributed on the inside. So like this. So like this right here. It's the opposite of that. Okay, when we had that and we distributed, then we have 2x squared plus 4x squared plus 2x. Okay, the GCF for all three of these terms is 2x. Okay, so we're factoring it out. So before we were distributing it inside, now we're factoring it out. We need to figure out a GCF between all the terms to factor out. Okay, let me see what it wants you to put in those two blanks. I got it right here. List out all the factors, find the largest variable. I don't love factor trees, I just don't. Okay, so we're just going to do it the way we want to do it. I'm not a big fan of factor trees. Okay, so let's just jump into it. Find the GCF between the two numbers. That's really three numbers or three terms. So let's scratch that out. Let's put 2 or 3 terms. Are they all three? Yep, they're all three. 3 terms. Okay, so GCF between 15, 30, and 45. Okay, this is where thought process needs to come in. Okay, and you can list out the factor trees. You can list out the factor trees in your head. You can list out the factor trees on the paper, however you guys want to do it. But in my brain, I see 15, 30, and 45. I immediately go to 5. I kind of like the guess and check method. So let's factor out a 5 between all three of these. So we have 3, because when I factor out, it's really saying dividing. Okay, so 15 divided by 5 is 3. 15 divided by 30 is 6 and 9. Okay, now here's the next thing I do. I look at it and I say, is there anything more I can factor out here? Okay, is there any other number that can go into all three of these? If so, let's factor that out then. You want to get the largest possible, greatest common factor out. But if you don't get the greatest, like in this case, I didn't get the greatest. Okay, we can also factor out a 3 from all three of them. Okay, so let's factor out a 3. And remember, when we already have 1 on the outside, we just multiply them two together. So right here, we just want to multiply. So we have 15, 1, 3 divided by 3 is 1, 6 divided by 3 is 2, and 3 for 9. That's it. So 15. Now, could you see that right off the bat? Yeah, but if you don't, is it that big of a deal? No, just keep going. Okay, so now we got 18, 33, and 36. Okay, so 18 and 36. 18 times 2 is 36, so, but 18 doesn't go into 33. Let's try 3, because 33 is the kicker. Only 3 and 11 go into 33. So let's try 3. Okay, so I factor out a 3. I get 6 on the inside. I get 11 and 12. Now, is there any other factors that go into all three of them? No, we're done. Boom, factored. All right. Okay, now variables. Variables are a little bit different. Okay, the greatest common factor of a variable, for like in this case, when you have all of the same variables, we have all of the same x's. Okay, and we just have x's, no coefficients. What we're going to want to do is take the smallest amount of x's that we have, which is x to the third, the smallest power, and then that's what we want to factor out of all three. Watch what happens. So I want to factor out an x to the third because it's the smallest from all three. Now all we got to do is take this exponent and subtract 3 from it because we're taking away 3. Okay, so 8 minus 3 is going to be 5, x to the 5th x to the 7 minus 3 is 4. And this is just going to be 1. Okay? Because remember, we're dividing. So this should look like this. Factoring out just means dividing out from all three. Okay, that's how we get those numbers. Okay, so that is factored. We are done. Okay, the next one, we have coefficients and variables. Okay, first things first, look at your variables. We have the same variable all throughout. We have x, x, and x. What's the smallest degree? Well, the smallest degree or power is going to be 1. So I know I'm going to have the x on the outside. But what else can we take? What's the greatest common factor between 4, 8, and 16? Well, it's going to be 4. Okay, so let's take a 4 out. Okay, so I'm going to divide each term by 4x. The first term is just going to go to 1. The second term is going to go to 2x to the subtract 1 third. And the last term is going to go to 4x to the second. Done. Can't factor out anything else. Okay, the hardest one. Okay, we have an x and y in all three of these terms. So we know we're going to get an x and y. Okay, the lowest power of x is just 1 right here. The lowest power of y is 1 right there. So I know I'm going to have an x and y on the outside. What's the coefficient going to be? Looking like 3. Because 3 goes into 9 and 18. So there we go. Okay, so if I divide every term by 3xy divided by 3xy divided by, well, that's already over it, so 3xy. Okay, so my first term becomes the 3's cancel, the x's cancel, and I'm left with, all I got to do is subtract 1 from 3, so y squared. The middle term becomes 9 divided by 3 is 3. I subtract 1 from the x because I already have an x squared, and subtract 1 from the y. Come on, get off there. Okay, so that'd be just 3xy. Okay, next one would be 18 divided by 3 is 6. Subtract 1 off the x squared, and I have no idea what oh, this is x to the first, okay? So it'd be x squared or y to the first, and then we would not have a y because we are factoring that out. Okay, so that is done. I don't have any more common terms between those. All right. Okay, here we go. Let's do some more. Okay. 7:43 in the morning. I shouldn't be yawning, but I am. Long week. Okay, greatest common factor here is going to be x. So let's factor out an x because it's the smallest power. So we're going to have x squared plus x plus uno. Okay, we can go a little bit quicker now. Here is going to be 2x. If you don't see that right away, that's okay. Just look at the smallest power x and the greatest common factor that we're going to have here, which is 4, 2, and 2. It's obviously going to be 2. Okay, so we want to divide each term by 2. So it's going to be 2x. This one right here divided by 2x would be 2x squared. We're just left with an x here and a 1. Oh, we're adding. So we're actually doing polynomials now. It's just going to be an x and then 1. So really it's the same thing. Just you have an addition or subtraction sign instead of a comma. Not a big deal. Okay, next we have a, b, c. We can't take any variable out because we have a, b, and c. We have none of the same variable in all three. Okay, but the coefficients, we can take out a 3, it's looking like. So we have, what, 5? 5a plus 12 divided by 3 is 4b plus 2c. Check, check, check. Okay. Okay, let's do some of the harder ones. The rest are pretty easy. It'd be, what's your greatest common factor here? Probably say 2. Yeah, 2. Here would be just y. And here would be 5. I'm guessing. Let me know if I'm wrong. I just did that pretty quick. Okay, let's do a couple of the hard ones. So this is what's actually going to need to happen. So here's where the guess and check is going to come into play. So I would, if I were you, I would get out your calculator and I would try to divide all these by what you think the greatest common factor is going to be. That way we don't waste time writing all the way out. We'll be okay. But if you don't want to do that, we can still do guess and check here. Okay. So, for example, let's just say I want to do 8. Why do I want to do 8? Because 88 is in the problem. Anytime you have something, a multiple of 11, that's what you always want to look at. Because 88 is only going to have 2 factors. It's going to have 11 and it's going to have 8. So if I factor out an 8, now 11 is in its simplest form. Okay, so let's factor out an 8. That's the first one my brain goes to. And then a C, because we have a C in all 3 of them. Okay, so we divide this by 8C. So 64 divided by 8C is going to be 8C squared, because we got 2 left over. 56 divided by 8C, 56C squared divided by 8C is going to be what, 7? 7 with 1 C left over. And here already says it's going to be 11. No C, right? C's go away. It's just 11. Okay, is that simplified all the way? It is. Okay, it is. Anyway, anytime you can get to a prime number in one of your factors, that's what we want to do. Like prime factor, you're good. Okay, this one's easy right here. What is it? What is the greatest common factor going to be here? Obviously 33 and Q. 33Q. Here's also easy. Let's do this one, the 4th. Okay, so what's our greatest common factor here? So we have A's in all 3. We have B's in all 3. Okay, what's my lowest power of A? It's going to be 1. So I know I'm going to have 1A. It's going to be factored out. And then I'm going to have, what, 2B? So B squared. Okay, and I think that's it. Okay, let's go through and divide everything by AB squared. AB squared. There we go. Okay, the first one's going to be A squared. And that's it. 2 B's get taken out. That's what we want. The other one, the middle one's going to be, if we're factoring A, it's going to be A squared again, B squared. Because we had 4 to start with. Last one's just going to be B squared. And that's factored. We're done. Okay, that's GCF. It takes some thinking. It takes a thought process. It's nothing there's not a formula that I can give you that will allow you to figure out a GCF. It's you have to think and guess and check. And if it looks like it can be factored more, then do so. Just if you already have something on the outside, just multiply by it. Okay? All right, let me know if you have questions. I'm available to Zoom anytime during the first hour. After school is tough because I got practice. So you're going to have to catch me at night. But send me a message and we can set it up. All right, see you guys.